Imagine trying to protect a computer system where the computers themselves spawn into existence, move at light speed across vast physical distances, and then just vanish entirely, all in a matter of seconds.
Yeah, it sounds completely impossible.
Right. Like, how do you even defend something that refuses to stand still?
Uh,
So, welcome to the WeCyberYou Unlock podcast, WeCyberYou. I am absolutely thrilled you are diving in with us today.
it is going to be a really fun one.
Oh, definitely. And hey, before we get into the weeds here, please take a quick second to follow the channel and visit WeCyberYou.com for more content exactly like this.
Lots of great stuff on there.
For sure. So today's deep dive is tackling this massive architectural challenge based on our sources covering architecting zero trust. The Container Firewall deep dive. We are basically figuring out how to secure the unsecurable.
And it really is the ultimate cloud-native security nightmare, because as you move your organization's workloads to, multi-cloud architectures, microservices, and serverless computing, those legacy ideas of security fundamentally break down.
Yeah, the ground is literally shifting under your feet.
Exactly. And the old tools, well, they just weren't built for this kind of terrain.
Okay, let's unpack this. We are going to bypass the basic definitions today because, honestly, if you're running a massive Kubernetes cluster, you already know the scale and the chaos we're dealing with.
Oh, absolutely.
Right. I mean, we're not talking about a traditional data center anymore. A container is just this lightweight software package with everything it needs to run, but it shares the host OS, making it super fast.
Right, and that speed changes everything. In a legacy environment, you had these long-lived servers, predictable network topologies, and highly static IP addresses.
That just map it all out on a whiteboard.
Yeah, you knew exactly where your boundaries were. But a modern container environment is inherently dynamic. I mean, you have hundreds or thousands of workloads communicating continuously.
Just a massive web of chatter.
Exactly. And they are scaling up automatically to meet traffic spikes, migrating across different physical hosts, and then spinning down into nothingness after completing a single compute task.
Securing a traditional network is it's kind of like protecting a medieval castle with a moat,
I like that analogy.
Yeah. You build a thick wall, you lower the drawbridge, and you just watch who comes in and who goes out. But securing this modern containerized environment is like trying to deliver secure mail in a bustling, shape-shifting city.
Where the buildings are literally moving.
Exactly. Skyscrapers are being built, relocated, and demolished every few seconds.
And that constant chaotic change is exactly why your traditional network firewall is just entirely blind in this scenario.
Because it's looking for street addresses that don't exist anymore.
Right. Those older firewalls were designed to inspect traffic entering or leaving a network. They watch the internet traffic, they monitor the VPN connections, and to do that, they rely heavily on static IP addresses.
But inside our shape-shifting city, a lot of this traffic might never actually leave the cluster to cross that traditional perimeter, right?
That is the big catch.
Because the monolithic application has been broken down, so now it is just dozens of microservices chatting with each other constantly over the internal network.
Completely. The vast majority of the traffic is internal chatter. And because those short-lived workloads frequently change their IP addresses as they are destroyed and recreated, any security policy based on an IP address becomes utterly impossible to maintain.
Right. It's just plain whack-a-mole.
Yeah, by the time your traditional firewall applies a rule to a specific IP, the workload using that IP is already gone, and an entirely different application has taken its place.
And this is where I start getting a headache.
I don't blame you.
If everything is moving and IP addresses are completely useless because they rotate every few seconds, how can a firewall possibly enforce a rule?
It sounds like magic, but it's not.
I mean, how does it know who is talking to who? You cannot write a rule for a ghost.
Well, you have to abandon the old way of thinking entirely. You introduce a specialized container firewall, and you stop asking traditional IP-based questions like, can traffic from IP address A reach IP address B?
Okay, so what do you ask instead?
Instead, you ask a workload-aware, identity-based question.
Meaning what? Like, is this the billing app?
Essentially, yeah. It asks, should this specific container running this specific application be allowed to communicate with that particular service using this specific protocol right now?
Oh, wow. So it's hyper-specific.
What's fascinating here is that the firewall assigns identities based on cloud-native attributes rather than network location. It pulls metadata directly from the orchestration platform.
So it's looking at the DNA of the container, not where it lives.
Exactly. It looks at the container image signature, the Kubernetes namespace it lives in, the service account it is tied to, and the specific labels applied by the developers during deployment.
So security finally follows the workload itself.
It does.
If I think about trying to secure my smart home, but every device, like the television, the refrigerator, the thermostat, change its IP address every 5 minutes, I would go absolutely crazy trying to write network rules for that.
Oh, it would be a total nightmare.
Right. I would want a system that lets me write rules based on identity. Like, this is the television and this is the refrigerator, regardless of what their IP address happens to be right now.
That is a really great way to visualize it. It is a fundamental shift from securing the static infrastructure to securing the dynamic identity of the workload.
Makes total sense.
But the real magic is how this operates continuously under the hood to build those identities and actually enforce the rules in real time.
Yeah, I want to see this in action. Let's forget the abstract theory for a second.
Sure, let's do a scenario.
Walk me through it. Let's say a sophisticated attacker manages to exploit a zero-day vulnerability and compromise a single front-end pod in my cluster. What actually happens from the firewall's perspective?
Okay, let's trace that attack. The moment your front-end pod was spun up by Kubernetes, the container firewall was already engaged.
It's just sitting there waiting.
Right. It does not wait for a human to manually configure it. It automatically discovers a new workload and immediately assigns it a unique identity based on its attributes.
Okay, step 1 and step 2, the playbook. Discovery and identity mapping.
Exactly. It knows this is a front-end pod operating in the production namespace using a specific signed container image.
Okay, so the firewall knows who the pod is, but how does it know what that pod is supposed to be doing versus, what the attacker's making it do?
That brings us to step 3, communication mapping. It establishes a behavioral baseline.
So it watches it for a while.
Yeah, before enforcing any hard blocking rules, the firewall spends time observing the natural communication patterns of your application. It maps the identity to the traffic.
Okay, I get it.
It learns that this front-end pod normally talks to the API service over port 443, it talks to a specific caching service, and it sends a relatively predictable volume of traffic.
It is like studying the natural traffic patterns of a city for weeks before you even decide where to install the stoplights.
That is exactly what it is doing.
You have to know how the city wants to move first so you don't cause a massive traffic jam. But hold on, I do have to challenge this a bit.
Go for it.
If the firewall is constantly observing every single packet and every single connection across thousands of workloads moving at light speed, doesn't that introduce massive latency?
That is actually the most common concern engineers have.
I mean, how does this not just grind the whole cluster down to a crawl?
It comes down to the architecture. These firewalls are not external appliances where you have to route all your internal traffic out of the cluster, inspect it, and then send it all the way back.
Oh, so it's not making a round trip.
No, not at all. They sit right inside the cluster, natively integrated. The inspection happens locally, often right next to the workload itself.
Wow, okay.
It checks the source identity, the destination identity, the protocol, and the port with incredibly low overhead because it is operating within the very same environment.
Okay, so the overhead is managed. Back to our attacker. They're sitting in the compromised front-end pod. They start poking around, trying to find the back-end database holding all the sensitive customer records.
And that is exactly where they hit a brick wall, which is step 4, policy enforcement. Administrators use that mapped baseline data we talked about to define explicit least privilege security policies.
Meaning you only get access to exactly what you need and nothing more.
Right. The rule explicitly states that the front end is allowed to talk to the API, and the API is allowed to talk to the database. But there is a strict rule blocking the front end from ever talking directly to the database.
So the attacker tries to bypass the API, and step 5 kicks in, traffic inspection. The firewall simply drops the connection because the identities don't match the allowed policy.
Exactly. It does not matter what IP address the attacker is using.
That is brilliant.
And the firewall takes it a step further with step 6, runtime protection. It constantly monitors for anomalous behavior.
Like what kind of behavior?
Well, the attacker might try to open a new listening port, initiate an unusual network scan to find other vulnerable pods, or attempt to establish an outbound connection to an external command and control server.
It spots the anomaly. So what is the response? Step 7, right. Does it just send an alert to a dashboard that a security engineer might completely ignore until Monday morning?
It can absolutely be configured to automatically respond. Based on the policy, the firewall can instantly quarantine that compromised pod.
Just cut it off completely.
Yeah, it isolates it from the rest of the network, severing all of its communication lines while keeping the container alive so your incident response team can conduct a forensic analysis.
Well, that's smart. Keep it alive to study it, but trap it.
Exactly. It generates immediate audit logs, and because the enforcement happens right next to the workload, the threat is contained at the source before it can spread.
And that concept of spreading brings us to a massive revelation in our source material regarding east-west traffic.
Yes, this is a critical distinction to make. One of the primary responsibilities of a container firewall is protecting that internal chatter, which is the east-west traffic between containers.
Just to clarify, that's like a microservice talking to an authentication service.
Yeah.
Or a front end talking to an API, right?
Exactly. These internal communications often represent the vast majority of traffic within a Kubernetes cluster, yet traditional perimeter firewalls rarely, if ever, inspect them.
Because they can't see inside the city.
Right.
If traditional firewalls are just watching the front door, the north-south traffic coming from the internet, then container firewalls act like bouncers, checking IDs at every single door inside the club.
I love the bouncer analogy.
Yeah, you might have bypassed the front door security to get into the building, but you cannot move from the main bar into the VIP room without getting your ID checked all over again.
And to push your bouncer analogy even further, these internal bouncers are not just glancing at a printed ID card that an attacker could easily forge.
What are they doing then?
They are verifying cryptographic identities. The source text highlights that modern container firewalls deploy alongside service meshes, like Istio or Linkerd.
Oh, I've heard of those. Explain how that integrates with the firewall, though.
So the service mesh provides mutual TLS encryption. This means that both sides of the communication, the sender and the receiver, cryptographically authenticate each other before a single byte of data is exchanged.
Okay, so it's a two-way handshake based on MEM.
Exactly. The container firewall leverages this deep observability to ensure that the identity of the workload is mathematically proven before evaluating the traffic against the security policy.
Here's where it gets really interesting, because the source material introduces a specific term for that internal bouncer concept, microsegmentation.
That's a buzzword.
Yeah. Instead of allowing unrestricted communication once you are inside the cluster, every container communicates only with explicitly authorized services. This limits lateral movement, so an attacker cannot just roam free if they manage to breach one single container.
And if we connect this to the bigger picture, microsegmentation is a foundational building block of zero trust.
Right. Trust nothing.
Exactly. In a zero trust architecture for containers, you do not trust a workload simply because it happens to reside safely inside the same Kubernetes cluster as everything else.
Proximity doesn't equal trust.
Never. Trust is never implicit. Every single communication request must be authenticated, authorized, logged, and continuously evaluated against the policy.
Wow.
Only explicitly approved communications are permitted. Everything else is dropped.
The level of integration required to achieve that is just staggering. The text points out that these firewalls integrate deeply with Kubernetes natively.
You have to.
Yeah, they have to understand pods, namespaces, deployments, replica sets, network policies, and ingress controllers. The security policies automatically adapt when workloads are created, moved, or deleted by the orchestration platform.
It is a highly specialized cloud-native integration that requires a deep understanding of how modern applications are orchestrated.
So what does this all mean for our old security tools?
Good question.
Are we just, I don't know, throwing away our traditional network firewalls, our web application firewalls, and all that legacy gear now that we have this incredibly smart, identity-aware container firewall?
The text is very firm on this point. Absolutely not.
Okay, so we keep the moat.
You do not throw away your existing tools. Container firewalls are highly specialized for protecting cloud-native workloads, but they are not a complete silver bullet cybersecurity solution on their own.
They just handle the messy internal stuff.
Right. They complement, rather than replace, your network firewalls, web application firewalls, endpoint detection and response tools, and security information and event management systems.
So they work as part of a layered defense team.
Defense in depth is still the golden rule here. You still have to secure the underlying container images by scanning them for vulnerabilities.
Makes sense.
You have to secure the container registries, you have to lock down the host operating system runtime environments, and you absolutely have to secure the orchestration platforms themselves.
Because if someone hacks the orchestrator, it's game over anyway.
Exactly. The container firewall handles the network microsegmentation and runtime behavioral analysis, but it relies on the rest of your security stack to protect the broader ecosystem.
Got it. Let's dig deeper into the actual threats. The sources lay out the threat landscape, but I want to understand how the firewall stops these specific attacks, not just of what they are.
Sure, let's run through them.
For instance, The text mentions detecting container escapes. How does a firewall, which monitors network traffic, stop an attacker from breaking out of the container to reach the host operating system?
It comes down to monitoring the specific pathways an attacker has to use. When an attacker attempts a container escape, they're trying to break out of the container's logical isolation.
Right, they want root access to the actual server.
Exactly. And to do that, they often have to interact with the underlying host infrastructure. The container firewall monitors the network interfaces and recognizes when a workload attempts unauthorized communication directly with the host's metadata services or internal APIs.
Oh, so it sees them reaching for the doorknob.
Yes. It identifies that traffic as a severe anomaly and shuts down that unauthorized pathway instantly.
That's awesome. What about malware propagation? If a worm gets into the cluster, how is it contained?
This goes back to our microsegmentation discussion. A worm relies on scanning the internal network to find other vulnerable services to infect.
It's just looking for open doors.
Right. But the container firewall's least privileged policies dictate that the infected pod is only allowed to talk to a very narrow list of specific services.
So it can't scan anything else.
Exactly. The moment the malware tries to scan unauthorized IP ranges or connect to pods outside its explicit policy, the firewall blocks the traffic and flags a behavioral anomaly. It stops the lateral movement dead in its tracks.
And it applies the same logic to command and control communications, right?
Absolutely.
The attacker tries to phone home to download a secondary payload or receive instructions, but the firewall sees an unauthorized outbound connection to an unknown external IP and just drops it.
Exactly. It prevents data exfiltration by ensuring sensitive databases can only be queried by authorized internal services, stopping an attacker from dumping the data out to the internet.
It's like putting a lock on the exit doors.
Yeah. And it stops API abuse by protecting internal APIs from unexpected or malformed communications. It even limits the blast radius of supply chain attacks.
Right, because if a third-party container image you downloaded turns out to be compromised, the malicious code inside it is still restricted by your firewall policies.
It's trapped.
You cannot just start exploring your network freely.
It acts as a massive failsafe. It combats insider threats by restricting unauthorized communications, even if they are initiated by privileged users who have legitimate access to the cluster.
Even if the call is coming from inside the house, it checks the rules.
Exactly. And finally, it helps identify and limit malicious traffic generated within the cluster to prevent internal distributed denial of service attacks from overwhelming your own services.
That is an incredibly robust set of defenses.
Yeah.
And it all happens dynamically, automatically scaling right alongside the application. But where does this technology go from here?
It's moving incredibly fast.
I mean, we are already talking about automated discovery and mapping.
Yeah.
The source text drops some hints about the future of this architecture.
The future outlined in the text leans heavily into advanced automation and artificial intelligence. As cloud-native technologies continue to evolve in complexity, AI and machine learning are increasingly being used to automatically build those complex communication baselines we discussed earlier.
So the firewall is basically learning the city's traffic patterns completely on its own.
Exactly.
Utilizing machine learning to process millions of data points and then optimizing the stoplights without requiring a human to manually review the logs.
That is the trajectory. The AI will detect subtle anomalous behavior that might evade traditional threshold-based alerts.
Because it can see the tiny deviations from normal.
Yeah. It will automatically recommend highly optimized, least privileged network policies based on its behavioral analysis, and even automate the threat response when a breach is detected. Furthermore, we are seeing deeper native integration directly into DevSecOps pipelines.
Meaning what for the developers?
It means that security policies are no longer an afterthought applied right before a product launches.
Nobody likes that bottleneck.
Exactly. The policies can be defined as code and applied automatically the exact second new containerized code is built and deployed through the continuous integration pipeline.
That is huge.
It provides continuous, unbroken protection throughout the entire application lifecycle, from the developer's laptop to runtime, all the way to eventual decommissioning.
Which really brings us full circle here. We are looking at a fundamental shift in how we approach security architecture. Container firewalls take us from a rigid, static, perimeter-based defense, that big, heavy fortress door, to dynamic, identity-aware protection embedded right inside the cloud-native application itself.
That's a perfect summary.
It is security that moves, adapts, and scales, just as fast as the infrastructure does.
It is a totally necessary evolution. As containers continue to power digital transformation across every industry, these firewalls are a critical component for maintaining the incredible agility of the cloud while simultaneously enforcing rigorous zero-trust principles.
You just can't compromise on either.
No, you simply cannot have one without the other in a modern environment.
Well, you have been listening to the WeCyberYou Unlock podcast, WeCyberYou.
Yeah.
We really appreciate you taking the time to dive into this complex architecture with us today.
It was a great discussion.
Be sure to follow the channel and visit WeCyberYou.com for more deep dives into the technologies shaping our secure future.
And as we wrap up this deep dive, I want to leave you with a final thought to ponder based on that AI-driven future we just discussed.
Oh, let's hear it.
If artificial intelligence and machine learning are being used to automatically observe and learn what normal container communication looks like in this constantly shape-shifting city,
Right.
what happens when a very patient, highly sophisticated attacker figures out how to slowly train that AI?
Oh, wow.
If they introduce tiny malicious behaviors over a long period, they could potentially trick the machine learning model into accepting malicious behavior as normal. In a world of fully automated zero trust, who is double-checking the AI that watches the containers?
A shape-shifting city where even the automated traffic cops might be learning the wrong rules. That is definitely something to keep you up at night. Thanks for joining us. Keep questioning your perimeter, and we will catch you on the next one.